In this section of training, we're going to go through an intermediate drives example to show you the process and the how-to input them into Belt Analyst. I have this file open here, and as you can see, the setup of the conveyor is a 72-inch belt with a speed of 760. It's inclined, and it only has 2 drives on it currently, which we can see here. Now, on the bottom of the screen here, we can see that the running belt total power and the take-up mass is over spec'd, and we need to get those under 100% for this to run smoothly. We need to add intermediate drives here to ease the tension throughout the belt. Now, the process to do this, I'd like to do it in steps when it comes to Belt Analyst files. So if you want to follow me along here, I'm going to save this file as intermediate drives example and head drives only. Okay, so we have our original file in the folder still, and we can manipulate this one without changing the original file. So in order to determine where the out by drives need to be, we need to retreat this conveyor from the tail towards the head until everything is in spec, not out of spec. So to do that, let's go to the Flights tab. You can see here that we have a certain amount of carry flights here, and I've already broken these up into specific distances, so we don't have to manipulate it too much in this example like you may have to when you're designing these. But to start, we can click Flight 1 here, and let's just delete, let's say, 14 flights. Alright, so with 14 flights deleted now, we can see that the horizontal length of this conveyor is 9,300 feet. Now, it did help the take-up mass. It's underneath 100% now, and it did help the other two, but we still need to go a little bit further. So if we right-click again, we can delete 3 more. Boom. Now we're in spec across the board when it comes to designing this conveyor. The running belt is a little high, but that really has to do with how conservative you want to be when it comes to the belt rating. For this example, we want to keep the running belt tension in the 90s, preferably mid 90s like it is currently. And we can see at the horizontal length that these out by drives need to be 6,300 feet away from the head. So using this number, let's save this so we have this, and then open up our original file. And if we go to our Flights tab here, find the head, we can see that's 300, then 1,000, 2,000, 3,000, 4,000, 5,000, 6,000 or 6,000 feet here. So let's insert a drive here, and these are going to be dual drives at each station. For this example, we're also going to follow this during dynamics in the later course if you ever want to take the advanced dynamics online training course. And to do that, we need a segment of belt between each pulley, drive, etc. So I want to move one of these drives 100 feet out by and call that location good. Let's save this. Notice that our horizontal length and our vertical lift is consistent with our original values. The only difference now is we have those 2 intermediate drives at the same location. With that said, the running belt and the total power are still out of spec, and we need to drop those lower. So we need to add yet another location for intermediate drives. So make sure that this is saved, and then let's save a new file. Intermediate drives example, head and out by drives. Okay, so now we have this new file. Let's do the exact same thing we did before by retreating the conveyor, starting at the tail going towards the head. And let's delete 8 segments to start. We can see that they both dropped below 100 now, and the running belt at 96. Because I know this example, and to make this go smoothly, let's delete 2 more flights here. That'll save us a bunch of time on the back end. You can see it only dropped to 94%, and I'll come back to this later on why I deleted those last 2. So now with this example, we can see that the in-by drives need to be 12,300 feet away from the head, or if you compare flight 7 through 1, it needs to be 6,000 feet between the out-by drives and the in-by drives. So let's save this and open up our original file again. Go to the Flights tab and figure out 6,000 feet. Insert 2 drives. And once again, I'm going to move my out-by drive towards the head to have that belt segment in between both of them. Save this really quick. So as the file stands right now, the horizontal length and the vertical lift are still consistent with our original file. We've added 2 intermediate drive locations. You can see after we did that one that the take-up mass jumped above 100 again. Sometimes this happens if you go to the drives tab and expand these. You can see that the wrap angle for these drives are not 210. So if let's enter 210 for each of these to lock them in. And with the wrap angle locked in, you can see that the take-up mass dropped down to 85% again. So now let's go back to our profile and our tension graph. We can see that the running belt is still slightly above 100, and we want to drop that. Rule of note here, when you're looking at the tension graph and the peak of each drive location, if it's generally decreasing slope behavior, as we have, 1 or more intermediate drives need to be moved in by. Conversely, if it's an increasing behavior, 1 or more intermediate drives need to be moved out by. Now, to come back to why I deleted 2 flights in the other file, that's because I wanted this consistent behavior, so I knew that I needed to move 1 or maybe 2 out by, but I wouldn't have to change both locations. So on the Flights tab here, I'm going to move the in-by intermediate drives location more in-by towards the tail. You can see doing so, we did drop the running belt underneath 100 now, even though it's hugging it really tightly at 99%. The total power and take-up mass look good, like the way that looks. And glancing at the tension graph, we can see that each peak at the drive locations are more or less level, which is generally what we would like. And we want it this way so the drive locations ensure exact load balancing. One more step we want to do here is glance at the target tensions to determine the power supplied for each drive. We'd like the 2 intermediate drive locations to more or less take up the same amount of power, and in doing so manage power sharing. So let's click on the options folder and open up the target tension window. In this window we can see that the last drive, number 6, is auto, which is the drive on the head. Now drive 5 is also at the head, and it's not in auto currently because we have a belt segment in between the two, but we would like that location to act the same. So let's change this target to auto here. So now the drives at the head will automatically adjust depending on what we do with the intermediate drives. In the same effect, we would like the in-by drives to act accordingly, as well as the out-by intermediate drives acting accordingly. So to do that, let's change the out-by drives at each location to dual. And after we did that, notice that the running belt percentage now jumped above 100 again. We want to make sure that we get that below 100. With the changes made, the program now shows the running belt tension at a spec, but not to worry, when we updated the drive controls type, the tension value was set to a high value. We need to correct the tension value. To do this, let's close out of the target tension window really quick and glance over at the take-up tab. On the take-up tab, we want to notice this tension value, 38,000 pounds. Let's keep that in mind, put it in your database, and open up the target tensions again. Ideally, we want this same tension throughout the conveyor so it's all consistent. So to do that, let's input 38,000 into both of these locations. And you can see after we did that, the running belt percentage has dropped below 100 again, hugging it at 99%. But also notice when both intermediate drive locations are 38,000 that the running power is slightly off. To make sure that the running powers are load sharing equally, we need to adjust the target tension of one of these locations. The rule of thumb I like to use is to keep the out-by triple location the same as the take-up tension, which would be 38,000. So let's adjust the in-by intermediate drive location. Another rule of thumb that I like to use when we're adjusting the in-by intermediate drive location, if the running power is higher than the out-by location, which it is, we want to increase the target tension. So if we increase that to 39,000, we can see that we now actually dropped the running power below the out-by location. So now we need to fine tune this and try to lock it in here. So 38,850, that's our target tension for the in-by drives. And now that we have this load sharing, we can close this out and save the file. We have efficiently added 2 intermediate drive locations with power sharing, and that will conclude this example.